Welcome to Notes 4.7. Today we are going to focus on double triangle proofs. And at the tail end of Notes 4.6, we did a double triangle proof. And essentially the gist of a double triangle proof is you're given enough information to prove a pair of triangles congruent, but it's not sufficient to prove the pair of triangles that you need to prove congruent, if that makes any sense. So let's go ahead and do one. They've been kind enough to give us the statements side, and all we have to do are the reasons side. But eventually you're going to be writing these all by yourself. So let's see if we can't sort of tackle it from that perspective. What would we do if we had to write this on our own? Okay, so here are our givens. We are given that AD and BE bisect each other at C. So what does that tell me? Well, it tells me that this segment is congruent to that segment, and then it tells me that that segment is congruent to that segment. Okay, so I have two pairs of congruent segments. I either need a third pair of congruent segments or I need an angle. Well, fortunately for me, I've got this bow tie shape going on, which gives me an angle. So I have enough information to prove that this triangle right here is congruent to this triangle right here. Unfortunately for me, what I need to prove is that GC is congruent to FC, and those guys are in the middle of those triangles. So proving those two triangles congruent doesn't give me those segments, but it does give me parts of those triangles which can be used to prove those segments congruent. So let's go ahead and do that. All right, so as I begin my proof, I begin with my givens. So AD and BC bisect each other, bisect at C, and that was my given. All right, and then because of that, I marked down that DC was congruent to AC and EC was congruent to BC, and that is my definition of a segment bisector. Okay, now I also marked the angle ECD was congruent to angle BCA, and that was because I had that hourglass shape going on, and those are vertical angles. So vertical angles are congruent, okay, which means that my triangles are congruent. You fill in why those triangles are congruent. I'll wait while you do it. Okay, obviously they are congruent by side, angle, side, congruence. Okay, so now that I've proven those triangles congruent, all of their corresponding parts are congruent. So angle D is congruent to angle A, and that is because of CPCTC. Okay, and then the next part of this proof, they've said that DCG, which is this little piece right here, is congruent to ACF. Okay, well, that was not part of this big yellow triangle, which means that there must be another reason, and that reason is, once again, because vertical angles are congruent. All right, so now I've got, I didn't mark A and D, so we've got A and we've got D are congruent. I've got this side still from up here before is congruent, and this angle right here is congruent, which means that these two triangles are now congruent by, I'll wait while you write it down. Okay, angle side angle congruence. Okay, so there's my double triangle. First I proved one triangle, then I proved another triangle in order to get my pieces congruent. So now I can say that that thing that I wanted to prove congruent, those two segments, those two sides of the triangles, are congruent by CPCTC. So are you beginning to understand how this works? Good. Moving on to our next proof. Again, we have overlapping triangles, and we're given some information, and we need to prove some information. So let's see what we got going on here. All right, we've got AC, so this whole side is congruent to this whole side, which is a little difficult to mark, so I'm going to go ahead and I'm going to highlight that. So that is congruent to that. And then we know that AD is congruent to BD, so those two sides are congruent. maybe I should have marked that in a different color. So that is congruent to that. And basically what we have going on here is then if I draw this, then I have two congruent triangles. Now, we need to prove that CED, so I need to prove that this angle right here is congruent to this angle right here. And unfortunately, proving what we can prove doesn't prove that, which means we're going to have to do a double triangle proof, which makes sense because this is the section of notes about double triangle proofs. All right, so let's prove our first pair of triangles congruent. So there's my givens. And then that blue piece right there tells me that CD is congruent to itself. And you'll notice that I wrote CD is congruent to CD. If you look at these triangles down here, that's the order that CD is written in. So it makes sense that I would write it that way. Once again, when something's congruent to itself, that is my reflexive property. And this one is of segment congruence. Okay, so those two triangles are congruent, and they are congruent because I've got side, side, side. So side, side, side congruence going on. Okay, now that those triangles are congruent, all of their parts are congruent. So this piece right here is congruent to this piece right here. That's what this is saying, CP, CT, C. And then these guys want to talk about angle 1 and angle 2. Well, we know that angle 1 and angle 2 are going to be congruent to each other because they are vertical angles, and vertical angles are congruent. All right, which means that these two triangles are congruent, triangle AED and triangle BFD. Okay, I am going to ask you why those are congruent in the notes check. Okay, but for the intents of this proof, we have proven them congruent, so now we can go on and we can say that their other pieces, so angle AED, so this one right here, is congruent to BFD. That one right there by CPCTC, because once I've proven triangles congruent, all their corresponding parts are congruent. Okay, so here's where it gets a little weird. We need to prove that this angle right here is congruent to that angle right there. Well, with what I've got, I can do that in one more step. And I can do that if I remember something critical from a past unit. And what it is I have, let me see, these two are a linear pair, therefore they are supplementary. So I've got angle AED is supplementary to angle CED, and I've got angle BFD is supplementary to angle CFD. All right, because these guys are a linear pair, so that is my linear pair postulate. All right, and that allows me to make this next statement. CED is congruent to CFD, and the reason for that is because I have two angles that are supplementary to congruent angles, therefore they are congruent to each other. What theorem is that? I am also going to ask you that in the notes check, because I'm evil like that. So make sure you come up with an answer to that, which would complete our proof. Okay, final question in today's notes is, if given that same diagram that we've just been working in, if you are given that AC is congruent to BC and angle A is congruent to angle B, can you prove that triangle AFC is congruent to triangle BEC? If you can, by what postulate or theorem, if it's possible? I am going to ask you about that in the notes check. So be thinking about the answer to that question. All right, this concludes notes 4.7, which also happens to conclude our notes for this unit. If you have any questions over anything we've covered today or in past notes, please be sure to ask about them in class. Thanks.